And so today we're doing the same thing we did on Monday, which is working with equations. What do we see with equations that we didn't see before? There's an equal sign, okay? And then see, like, what were we working with before we got to equations? That it was like another E word. Okay, you gotta go to G119. You might not be to the whole period, but you gotta go to G119. What were we working with before we got to equations? Starts with E. It's been like 48 hours. It starts with EX, ends with expressions. Expression, yeah. So both equations and expressions contain variables. The difference is, in an equation, when you have an equal sign, you can now solve for that variable. If a variable is an unknown number, when you have an equal sign, by the time that you finish, you can say what that unknown number is. Yahtzee. Hey. Disculpa. This I already talked about last time, just to get you prepared to see the difference. Now, the different, like that's what's the same between today and Monday. The difference will be that in order to isolate that variable, as Donnie said, it's going to take multiple steps today. There's going to be more than, on Monday there was only one operation to cancel. On Monday there was only one operation to cancel at a time. Today there'll be multiple. So how do we get more than one operation to cancel in order to isolate the variable? Well, most books will tell you to go reverse order of operations, which we talked about. Do SADMAP. Get rid of adding and subtracting first, then get rid of multiplication and division, then exponents and then parentheses. But that can be confusing for some children, especially with those parentheses. Sometimes equations have invisible parentheses that you don't realize are there. So a less formal way of explaining it is that if you want to cancel out operations, work your way outside in. Start with whatever's the furthest away from the variable and work your way in closer. Always doing the opposite. So that's what we're going to just work on over and over and over again until we learn it. So we've talked about that equal sign being like a divider. It splits an equation into two equivalent expressions. By the time I'm done, one of the sides should contain only a variable. I like to leave the variable on whatever side it started with. So here are the variables on the left. What numbers are getting in the way of the variable being by itself? -4 and 3. Yeah, there's an 11 in the equation, but I don't care because that's already on the other side. I don't have to worry about that. So I like to explain this as saying the what, the when, and the how. So the what we need to cancel is the 3 and the -4. Now let's get into the when. Which one are we going to cancel out first, the 3 or the -4? The -4. You can say it's because of reverse order of operations. I need to cancel out subtraction before I cancel out multiplication, or you can say it's further away from the variable. The -4 is its own term. The 3 is part of the same term with the n. So +4 + 4. That's what we learned last time. Now we drop down 3 in. We drop down an equal sign. 11 + 4. And then you divide b and equals 4. That's why Donnie gets all the girls. That's funny. That's what I heard, like when they walk by you, they're like, man, that kid sure can solve an equation. And then, like always, not that I plan on doing this, but if you want to pay attention to detail and you feel that you have the time to do so, you can get your solution and plug it back into the original equation to see if you end up with two equal sides. What is 3 times 5? 15 minus 4 is 11. It checks out. Oh, the second problem, you already have a fraction. Oh. Well, it's not too bad. Don't worry about the fraction so much. Let's just worry about the variable. Kara, in order for the variable to be by itself, what do I need to cancel out? 2 and a 5. Good. That's the what. For the what, Annalisa, you definitely don't need phones. No, that's not going to help. Just leaving it exactly where it was before is not going to help. But the other thing you don't need is math. That I have, for this equation here, I have not asked you anything math related. I just said, hey, what's on the same side of the equal sign as the y? Okay, now is when the math starts coming in. So now we have Donnie's attention. So she said to get rid of the 5 and the 2. Let's talk about the when. Which one do we need to get rid of first? It would be the 2. You could say the 2 is further away. You could also say it's because of reverse order of operations. So the way you get rid of a plus 2 is minus 2. You drop down the y over the 5 as it took the spot. Gives me negative 10. Glasses. Last step to get rid of the 5. The opposite of division is multiplication, so multiply both sides by 5. Y equals negative 50. Facts. Ooh. Okay, let's start off with the easy question. Jade, let's start with a what. In order for the y to be isolated, what do I need to cancel out? Negative 4 and 2. Okay, but now this is where thinking of it like reverse PEMDAS gets a little confusing because, hey, Mr. Romero said get rid of adding and subtracting first, right? So that one leads you to believe, hey, you're going to get rid of the negative 4. But the thing is, in a fraction, fractions contain invisible parentheses. So if I'm going to go backwards PEMDAS, yeah, I know that looks like subtraction, but it isn't subtraction. It actually counts as parentheses. Parentheses will come at the end. So go ahead, Ferris. What am I going to get rid of first? Oh, why would you want to do that? Ugh, yeah. Oh, yeah, but that's silly. That's a waste of time. Donnie is a big opponent of more work. He's all for less work. Annalisa, or what do you want to get rid of first and how? Correct. Yatzil, amiga. What am I going to get rid of first? You want to get rid of the 10 that's already on the other side? Good job. Okay, descansa un poco. Joseph, what do you want to get rid of first and how? And how am I going to get rid of the 2? Good, yeah. I'm going to go times 2 times 2. But that's just going to show you that the 4 is going to come last. So I drop down on y minus 4, 20. Last step is just add 4. Where did the 2 come from? Well, this 2 on the bottom is already there. It's being divided, so what's the opposite of dividing? That's what I did. I multiplied by 3 to cancel this out, but if I do it on one side, I have to do it on the other side too. 10 times 2 is 20. Yes, Jade. Well, the number, the line that you're referring to is a fraction bar. A fraction bar is division. The opposite of division is going to be multiplying. But that's why I also try to teach you, think of it as what's further away. So like, if I know it's less formal, it probably is less exact, but if I were to ask you what's further away from the y, what would you say? 2, sure, it's in the bottom of the fraction, whereas at least the negative 4 is on the top along with it. So you start off canceling out whatever's further away and work your way in closer. Oh no. If you learned something from the first one, from Monday's lesson, what do we want to do here first? Yahtzee! Go ahead, Ferris. Good. Change the mixed number to an improper fraction. So that's 7 times 2 is 14 plus 1 is 15 over 2. Now here's something that we did not do on Monday. On Monday, we just learned to treat this as a regular equation and isolate, which only took one step. But here you're going to learn something new. If your equation is ever just one fraction equal to another fraction, right? There's nothing else there, right? Would you agree? The entire left side is a fraction. The entire right side is a fraction. Then now that equation has a special name. Anybody want to guess what that name is? I actually did mention it very, very briefly on Monday. Very good. It's called a proportion. And a proportion has a special way of solving. Yes. Now, what's a special way you solve a proportion? You like another clue? It starts with cross and ends with multiply. Yeah, you cross multiply. If 2 fractions are equal, their cross products are equal. So then I could say 15 times 2 is equal to 2 times x plus 3. Yeah, cross multiply. The thing is, you got to put the x plus 3 together. So yeah, on the left side, I can just do third. Oh, but wait, Mr. Romero, how about if I put the 2 times x plus 3 on the left and the 15 times 2 on the right? Oh, that's fine also. No matter which side you put it on. What do I have to do on the right side? Here. Huh? Being that I put the 2 times the x plus 3 on the right side, what do I have to do on the right side here? I have to distribute. Ferris, you've been dying to distribute, so there you go. So minus 6 minus 6, 24 is equal to 2x divided by 2. So this unknown number that was hiding from us has now been revealed. It's 12. Take that, 12. Pasted it the other way.
Well, I got the same.
Yeah, there's more than one way to do this, definitely. Donnie knows all the ways.
Okay. I'm gonna ask you.
Ooh. Wait, Mr. Romero, this is easy. These are like the ones we did on Monday. Because all I have to do is get rid of the 14. Au contraire, mon frère. I have to get rid of the negative also. And you're like, okay, well, fine. Let's just go one at a time. Let's get rid of the 14. Hey, that's subtraction, right? So the opposite of subtraction is addition. That
multiply both sides by 5.
Heck no. Not yet. Not yet.
No? Take 14 to 19 first. Okay. Or
The negative belongs to the x. So when it's time to get rid of the 14, which is that, we will get rid of that first. It's further away. It's going to be minus 14. Now here's where you can't forget, and this is why I even put that little special note on Monday's notes. When you drop down the x, you're not just dropping down the x. What else needs to drop down? And now, Ferris, now it's your moment in the sunshine. How do you get rid of a negative?
Both sides by negative.
Good. Just if you want to get rid of a negative, multiply by a negative. Anything times -1 changes sign. So x does equal -5. Ooh. Yeah, Ferris.
My thing so negative 2.
Good. Remember that an equation is just two equal expressions. So yeah, an equation is meant to be solved, but expressions are meant to be simplified. Later on, you'll also learn how to factor expressions, but one thing at a time. And most of the time in equations, they already give you the expression simplified, but if not, you have to simplify it. As Ferris just said, how can the left side be simplified? By combining like terms. What is negative y minus y?
Minus 2y.
Good, so 7 minus 2y is equal to -1. Somebody not named Ferris, tell me what I have to get rid of in order for the y to be by itself. Yeah, Donnie. Wait, my hand just went up. I just didn't even know how it got there. Never mind. Yeah, see, what do I need to cancel out in order for y to be by itself? A -2 and Donnie and a 7. So that's the what. That's what I'm focused on. But now let's go with a when. Which one would I get rid of first? The 7. Good. How am I going to get rid of that 7? -7. Excellent. -7. You might need to use your calculator here because you guys always mess up the rule of the signs. But -1 minus 7 is -8. Ronald, how are you going to get rid of that -2? Add. Diana, how are you going to get rid of the -2? Divide by -2. The -2 is being multiplied, so you divide. Oh. Donnie, you're going to have to pay for that later. Set them up. Watch your back, Donnie. He's coming for you. You like equations? No? Analisa does. Here, why don't you guys do that one? Raise your hand when you got it. You already got it?
No.
Then do it.
I already got it.
He's trying to take some of your girls, Donnie. Can't let him do that. What'd you get?
7.
Yeah. Yeah. Richard, what do you want to do first here? First I don't know all, but I want to know if you know. Nah. At least you tried. Yeah, Chantal. Good. Combine like terms. The 5 and the negative 13 are on the same side. 5 minus 13 is negative 8. All I did was I combined terms. The 5 was positive, the 13 is negative, so you combine that, it gives you negative 8. Now it's when I can start getting rid of first, make sure both sides are in simplest form. Now you can start solving. So I need to get rid of the 3 and the negative 8. The negative 8 comes first. I add 8 to both sides. 21, yes. Equals 3b divided by 3. 7 equals b. Well, we haven't done one like this. We have to see if you guys can come up with that one. Okay, well then you wait first. There's more than one way to do this, Donnie. You could distribute first if you want, or you could work your way outside in if you want. Don't be jealous first. Anybody other than Ferris got it? Kara, what'd you get? Yeah. So believe it or not, you could have actually started off dividing by 5, but the reason why because like, you could just say, hey, look, I have to get rid of the 5, the 2, and the negative 3, and the 5 is the furthest away. But the reason I would caution you with that is you have to divide, right? Dividing doesn't always work. So yeah, when you get lucky that on the other side, 15 can be divided by 5, but if it wasn't divisible by 5, what would you end up with? No, well, yeah, we don't need a fraction. Ugh. So I would advise you to distribute 5 times 2x is 10x, 5 times negative 3 is negative 15, and that equals 15. So now the numbers you need to get rid of are not 5, 2, and negative 3, it's just 10 and negative 15. Pharaoh, which one do you want to get rid of next? All right, so plus 15, plus 15 is 30. And then if you divide it by 10, Richard gets 3. Okay. Wait, come here. You see on the next one. Oh, you ruined it. Why? JK, LOL, BRB. Right on. What? Let's do this one together. Oh yeah, I know you see the fractions and stuff and you freak out. But more important than that is that we have 2 different ends. So before they can ever be alone, we have to get them together, like Donnie gets with the ladies. So in order to bring those fractions together, subtract them, yeah, we need a common denominator. So what's the least common denominator of 2 and 16? That's the greatest common factor. That's not the least common denominator. 16. So something over 16 minus something over 16 is equal to 3 over 8. The second 16 got to stay the same, so the second 2n gets to stay the same. The first, excuse me, the first fraction of 2 became a 16. How? Times 8. So take whatever's on top and also multiply it times 8. 8 times n is 8n. Now I can subtract. The denominator stays the same. Ronald will make sure of that. And then 8n minus 2n is 6n. What do I have now? What do I have now? You could. You just said you could do, but what, for the second time today, what do we call it when one fraction is equal to another one? A proportion. So if you choose to, you can do it the way that Ferris is saying to do it, which is to multiply by 16 over 6 on both sides. But yeah. Or I think it's easier to just cross multiply. 6n times 8 is equal to 16 times 3. 6n times 8 is 48n. 16 times 3 is 48. So then we divide both sides by 48. So n equals 1. He's a master solver. Not you.
Done?
Did I put the same one twice?
Oh, yeah.
Maybe I did. Yeah, I normally do that when I want to do it another way, but the only other way that I would show you, I don't know if I want to show you yet. Yeah, let's do it. It's fine. Okay, what was the first step on the last one? Yeah, okay. And what did the common denominator end up being? 16. Well, you can use that common denominator two ways. You can use it to make the denominators the same and bring the fractions together, or you can use it to get rid of all the fractions. But the thing, I just don't know how helpful it is because you still have to be able to work with fractions a little bit. Just now, instead of adding fractions, you have to know how to multiply them. What did we say the common denominator was? 16. So watch, here's another thing you could do. You could get that 16, the same 16 we had, but now multiply everything by 16. If you do that, what that guarantees you, assuming you do it correctly, is that there should be no more fractions on the next step. You simplify. 16 times n is 16n divided by 2 is 8n. 16 times, this 16 on top cancels out with the 16 on the bottom. Or you could say 16 times 2 divided by 16 gives you minus 2n. On the other side, 3 times 16 is 3 times 16 is 48 divided by 8 is, remember this is 16 over 1. 48 divided by 8 is 6. 8n minus 6n minus 2n is 6n. So the same way we did the last time, we still 1. Two different ways, same solution. What do you hate more, Richard, equations or fractions? Both equally. Ooh, decimals. One of the things I try to stress to my students is every time you see decimals, you should never freak out. Just when you see decimals, think of calculator. That's it. That's the only thing you're really gonna need if you have a calculator. But the steps are the same. If I want to get g by itself, what do I need to get rid of?
Subtract.
What do I need to get rid of? What's the what?
1.12.
1.12 and
1.25.
1.25. Okay. So which one should I get rid of first? 1.12. So the only thing that's different between this and the other ones is that, yeah, you might need a calculator. But the steps are the same. It's not like fractions where you have to know special rules.
9.74.
You guys are passing each other's notes?
9.74.
You're too young to go to prom, so I don't know what exactly you're. It's
7.5.
And then if you divide by 1.25, again, you might need a calculator. What's 7.5 divided by 1.25? Put it in the calculator that you all have. What diz, Joe? ¿Y tu calculadora, Luis? Yes, Jake. 6. Fax machine. With decimals? Well, yeah, you're not completely out of luck, but yeah, it's not looking good. What's different here? Variables on both sides. Well, yeah, remember that we want to isolate the variables just before we can start worrying about isolating. We need to get them on the same side. What irritates me is when I see these, so many kids are like, oh yeah, you go +1, but why? What should have your attention is the variables. The variables should draw your attention first. I want to bring them together. I want them to be on the same side. So, I know you guys think of it this way. I either need to move the 5x to the left, to the right, or move the x back to the left. And the thing is, you can do either one. It doesn't matter. I like to move the one with a smaller coefficient. The x on the left has a 5 in front. The x on the right has a 1 in front. Which one's smaller? So that's the one I'm going to want to move. But I can't just move it because I'm a mathematician. How do I move that x to the left? Minus x. So if I do minus x, now all the x's are on the left side of the train tracks. And they're coming to take over. So if you don't have an x, you can't be on the left side anymore. I know a lot of teachers will teach you to combine like terms now. I just like to just rearrange. I like to do it all in one step. So if the x's are all on the left, who do they have to get rid of? What term on the left side does not have an x? The negative one. So let's just get rid of that now. +1, +1. So instead of taking 2 steps to do it, in 1 step. Look, how many terms did we start with at the very beginning? In the entire equation, how many terms were there? 4. How many terms do I still have? 1. Richard, look, 2, 3, 4. I still have 4 terms. The difference is now they're like, I can combine them. 5x minus x is 4x. 15 plus 1 is 16. Divide by 4. X is 4. You guys want to give this one a shot? If you did it. See if you can solve it. Raise your hand when you have it. Oh, you got it already? What'd you get, Ferris? Yeah. What'd you do first, Ferris? Yeah, if you distribute the one that's in front of this parentheses, everything just stays the same. But now that the parentheses is gone, what can I do now that I couldn't do before? I can combine the g's on the left. G minus 3g is negative 2g. And now this becomes exactly like the last problem. I still have g's on two different sides. I like to move the smaller coefficient first. So I'm going to move the negative 2g over to the right by adding 2g's. Now the g's have decided to take over the right side of the equal sign. And if you don't have a g, you can't be there anymore. What term on the right side does not have a g? The 1. Yes, on the right side. 1. Anymore, so minus 1. Now I can combine like terms. 4 minus 1 is 3. G plus 2g is 3g. Divided by 3. All the children rejoice because g is 1. Any questions? Winding down. Ooh. Well, let's see. Yeah, we have ends on both sides, and not because you have to. I just prefer it because we get to avoid the negatives. I like to move the one with a smaller coefficient. But look, what does this the first n have in front? Negative 1. What does the second n have in front? A negative 1. So regardless of which one you choose to move, you're doing the same thing, which is plus n. And if you do that, all the n's cancel. But Ferris, before you just get ahead of yourself and be like, oh, no solution, that doesn't necessarily mean that there's no solution. It means drop down what's left over. When all the variables cancel, drop down the leftovers. So right now what we have is a statement that says that negative 24 is equal to 5. Is that a true statement? Because it's not true, that's why there's no solution. If you ever see it, a symbol for no solution is called the empty set. I'm a mathematician. Ooh. When do you have okay. Before you leave, get a password so you can come to it if you gotta make up the test. It's already been almost a week. What's the first step? Distribute. What's half of 10? Half of 10 is 5, so I have 5y. What's half of 4? 2. Well, before you get too excited, let's just go one step at a time. Just like in the last one, we have y's on both sides. I have to move it together, but no matter what I do, when I subtract 5y, all the y's cancel. Ferris gets all excited and goes, hey, no solution. All the y's canceled. But that's why I told him to drop down the leftovers. Here, I have a statement that says 2 equals 2. Is that a true statement? No, I distributed. Half of 10y is 5y. Half of 4 is 2. I distributed. There's no more y's, but I'm left with a true statement. If what I'm left with is true, it's not no solution. It's really all solutions. It's called all real numbers. That means that I can go to every single one of you and say, Ferris, give me a number. Tayson, give me a number. Diana, give me a number. Joseph, give me a number. Everybody gives me a number and I plug it in for y at the beginning. I'm always going to end up with two sides. Unless Chris does it because he's half asleep. So he won't be able to give me a number. Everybody else can. For the third time today, what do we call these? Proportions. How do we solve the proportion? Cross multiply. So 4 times x is equal to negative 3 times 26. So 4 times x is equal to is negative 78. Is that wrong? I don't know when. And then when I divide by 4, what happens? What happens when I divide by 4? 78 divided by 4. No, you wait. What is 78 divided by 4? Well, you get a decimal, yes. And we don't like decimals. So, I mean, it's one of those where as long as you're not rounding, if you were to give me an answer that's a decimal, I guess I could live with it, but I don't like it. So what I always like to teach is if you can't divide, then reduce. If I can't divide these by 4, is there another number that I can divide them by? By 2. So divide each one by 2, that gives you negative 39 over 2. Donnie, don't do it, Donnie. Don't do it. Don't do it. The girls will always be there. Your math skills will always be there. The girls will always be there. You don't need to text them, man. They like a guy that plays hard to get. Make them chase you, Donnie. Donnie never cries. You're not the only one. Okay, for the 4th time today, what do we have here? Proportion. How do you solve a proportion? Or as Richard says, the butterfly. Allegedly. So 3 times A is equal to 15 times 2. So 3 times A is equal to 30 divided by 3. A is equal to 10. And finally, look, the last one we've been able to finish. So it's good. That means that then tomorrow, I'll use the extra time for tomorrow to get back to test and go over it. For the 5th time today, what do we have? A proportion. But when you have more than one term, like you have with a b plus 4, that b plus 4 needs to stay in a parentheses. Ashley, how am I going to get rid of the parentheses?
Wait.
Distribute 4b plus 16 is equal to 35. So now just minus 16. 4b is equal to cross multiply. 4 times b plus 4, 5.
Okay.
That was 19. So if you divide by 4, 19 cannot be divided by 4 or reduced. So just leave it as 19. Finito.